Hello and welcome to our next algebra lesson. We're going to start a module of work on simultaneous equations, which is new to us at the moment. And we're going to start off by looking at what it means graphically to solve a simultaneous equation, since we've been working with graphs, because it will allow us to practice the skills we've been learning. And also it gives you a really good idea of what you're doing when you solve a pair of simultaneous equations. And then we'll move on to looking at solving them algebraically in the lessons that follow. So what you can see on the screen are two equations, y equals 2x minus 2 and x add y equals 4. So when we say let's solve these simultaneously, what we mean is let's find a solution that will work for both of these equations at the same time. And to do that graphically, what we're going to need to do is plot both of these straight lines. So for the first one here, we have just done the gradient and intercept method, so we can use that. You could, if you wanted to, draw out a table, that would be fine, but the gradient and intercept method is going to be a bit quicker. So what do we know when we look at this equation? We know that the intercept is -2, so we can put a point on our graph, assuming, I haven't numbered these axes, but assuming each square is worth 1 unit. So here we are at -2, and we know that our gradient is 2 as well. So we know that for every 1 square along, we're going up 2. Now, usually it would be 1 unit along the x-axis and up 2 units on the y-axis. So remember, you have to be a bit careful of the scale, but I'm assuming here that every square is 1. So I would then be going from my intercept along 1 and up 2. So my next point would be plotted here, and then along 1 and up 2, and so on. And once I've got some points plotted, I can join those up to make a straight line. Now, actually, for this equation, there are an infinite number of solutions for x and y, and any value for x and y that is sitting on this straight line will be a solution for that equation. So an infinite number, and they're going to go well beyond where I've drawn that line. They're going to continue on down, and they're going to continue up. So moving on to the next equation then, I've got two options. I could rearrange it so that it's in the form y equals mx plus c, and then I could read off the gradient and intercept and use that method. So what I would have to do then is subtract x from both sides. So now I can see the intercept is 4 and the gradient is -1, so along 1 and down 1. But when you've got an equation in this form, you should be thinking about the cover-up method, because it's just, it's quicker and it's easier. So I'm going to cover up y, and that tells me y is 0. So what is x when y is 0? Well, x must be 4. So I'm going to plot a point at x is 4, y is 0, which is just here where the green dot is. And then I'm going to cover up x, and that will allow me to work out what y is when x is 0. And in this case, it's very straightforward. Y is also 4. So I'm going to plot a point at x is 0, y is 4. And then I'm going to join those 2 points up. And that gives me my other graph. But as I say, you could have done intercept at 4, which you can see over here. Gradient is -1. So along 1, down 1, along 1, down 1, and so on. Okay, so now I've got both of those plotted. Again, there are an infinite number of solutions for that second equation. Anywhere on this line, including all the decimal values, will be a solution for x plus y is equal to 4. So there are an infinite number. But there is only one value for x and y that will solve both of them at the same time. And that is where the two graphs intersect. So at this point right here, so that is x is 2, y is 2, and that is the solution for these pair of simultaneous equations. So the point of intersection where the two graphs cross, that is where you will find your solution for both equations. Now, because we'll be dealing only with linear equations, there will only be one solution. If we were looking at quadratics, then you would have more than one, but we only need to worry about one solution for what we're doing today. Sometimes on the exam, they give you an already drawn graph and they just ask you to read off the solution to the pair of simultaneous equations, and that's just about realising that that's all about the point of intersection. Sometimes you might have to draw the graphs out first of all before reading off the solution. So your work today, it's more than you can see on the screen here, so I've uploaded the worksheet for you to the assignment. And you don't have to print this off because you can just draw out your axes into your book. And you've got to plot these straight line graphs, both on the same pair of axes. And you can do that using gradient and intercept. Sometimes it might be more sensible to use the cover-up method, and that's where you've got X and Y on one side. And sometimes you might prefer to draw out a table. So it is entirely up to you which method you use, but you've got to draw out your graphs and then read off the solution, realising that that is the point of intersection. Now this is going to be really great practice for drawing together all of the stuff that you've learned on straight line graphs, as well as thinking about simultaneous equations and what it means to solve those. And then next lesson we'll move on to solving them in a more algebraic way.